Here we are, proteins part 2. Let's do this. Last time we talked about how amino acids are linked together with a condensation reaction to form a long chain, and that long chain is called a polypeptide, and that is our primary structure of our protein. But our protein has 3 more stages of development, if you will, before it becomes a full-fledged protein. So let's back up a little bit. We saw in our amino acids that they have all the same identical base with a nitrogen on one, an amine group on one end and a carboxyl group on the other, but they have different side chains. The symbol for side chains in these models is often R. So when we look up here, we see our nitrogen group, our carboxyl group, and then we see an R. This is the side chain for whatever amino acid this is. Then they have peptide bond between the carbon and the nitrogen. The central carbon has another R. So you can see the R's alternate. So the side chain here is down, the side chain up here is up, down, all the way through. Now, why does this matter? Because side chains are not islands to themselves. We've already discussed how, they can be divided into polar characteristics, nonpolar, polar covalent, and ionic. Well, what does that mean? Well, that means they have further interactions with each other. So when you have those side chains sticking out toward each other, well, things can happen. Here we've got a hydrogen bond between partial charges of these two side chains. These are both hydrophobic, and they are getting pushed together by other polar interactions. This is a straight-up covalent bond between two side chains. So sometimes the side chains bind directly to each other to share electrons, and then we have ionic bonding between them. So polarity matters. Polarity further influences the change of the molecule. So they don't just stay in this form, they can have further changes, and those further changes are called the secondary structure. There are 2 common motifs to secondary structure. That's what we call them, the patterns that come up over again, these 2 motifs. One is the alpha helix, and in the alpha helix you get a corkscrew shape because some of the amino acids hydrogen bond with later amino acids, and as this pattern continues we make a corkscrew shape. So you will see in many protein models, if you look them up, you will find lots of corkscrew patterns. Those are all alpha helices, and that's a secondary structure. Another secondary structure is called a beta sheet. And what it is you have your polypeptide strand, and let's say it continues going over here, and then it does some stuff, but it comes back and it runs parallel to the original strand. And then it does something and it runs parallel to the original strand. Well, when you have these parallel strands running in concert like this, they can form hydrogen bonds with each other. And so now there's a connection between these 3 strands, and there could be more. It can go on, but when you do have these connections, you would call that a sheet. And so now, in this model, we've got our alpha helix, and then the sheets are shown as broad, flat arrows, because there are more than one length of that polypeptide long. There's at least 3 here, so this is a sheet. So our secondary structures are alpha helices and beta sheets. So what is our tertiary structure? This is not the very best picture of this in the world, but a tertiary structure, well, you've got your alpha helices, you've got your beta sheets, but you've got a whole bunch of stuff going on out here that also has polar and nonpolar interactions that are not alpha helices and not beta sheets. The way the rest of the polypeptide folds around your beta sheets and alpha helices, that's your tertiary structure. So you can consider it as the final ultimate folding of that protein. That is your tertiary structure. Now, for some protein, this is it. They've been turned into a polypeptide. They have their helices and their sheets form, and then they curl around those, and they're done. But not everybody. Sometimes you'll get a cooperative group. You will get, in this case, it looks like we have 5 different polypeptides that sort of come together and superfold with each other to give us one functional protein. So the 4th stage, the quaternary structure, is a combination of multiple tertiary stage polypeptides. So that's 4th level. They come together, and now you've got your finished protein. This is going to do some job for the cell. And I guess we're going to have to do proteins part 3. Well, Here's a spoiler. There's a part 3. Good luck. No luck. Luck, no. We don't rely on luck. We struggle well. That's what we do. Forget luck. Nobody needs luck. We need effort, commitment, priority. Struggle well.